You can think of Excel as being like a giant calculator that does many different mathematical operations. In order to benefit from these features, you have to conceptualize the result that you want, what you're trying to do, or the number that you're trying to calculate, and then you have to describe it to the software in a way that the software can understand, so to speak. The most important first step for writing formulas and using functions in Excel is that you always start with an equal sign. I'm going to start with a really basic example, and I'm going to skip the equal sign just this time. I'll type the number 2 in cell A2, the number 3 in cell B2, and I'll type the number 5 directly in cell C2. I can see that 2 plus 3 equals 5, but of course the software doesn't see this data in the same way that I do. So far, the software just sees 3 separate numbers and it knows nothing about how these numbers are related. I'll show you a couple of ways to get the same result. Now I'm going to type inside of row 3. In cell A3, I'll type 2, and in B3, I'll type 3. In cell C3, this time I'm going to do something different. I'm going to start with an equal sign. I'll click on cell A3, manually type a plus sign on my keyboard, and then I'll click on cell B3. I've built a formula. In cell C3, I wish to calculate the total of the values in cells A3 and B3. When I press enter, Excel will calculate that the sum of these two numbers is 5. Recall, in row 2, I typed each one of the numbers directly. You just saw me do this, but if you received an Excel workbook from someone else and you didn't know how it was created, you could click inside of each cell and look at the value of the numbers in the formula bar, 2, 3, and 5. If I do the same thing in row number 3, again I see 2, 3, but when I get to cell C3, it says equals A3 plus B3. Another way to conceptualize this is that I've instructed Excel to add together the contents of cell A3 and B3, regardless of what numbers are contained in these cells. Watch what happens if I change the value of cell A3 to 7. When I press enter, the result in cell C3 automatically updates to become 10. If I return to row 2 and change the value of cell A2 to 7, you'll notice that nothing changes in cell C2 because there is no formula in cell C2, only the plain value 5. By using formulas, we're going to be able to do mathematical calculations in a way that's convenient even if our data changes from time to time according to the context of our spreadsheet. The difference between my examples so far is that in row 2, I've typed the values directly, and in row 3, I've written a formula that incorporates references. Think about values as the actual number, and think about references as signs that point at numbers. I'm going to clear my worksheet by clicking in this area between the headings A and 1, and then I'm going to go to the Editing group, the Clear command, and I'll select Clear All. You need to know the basic mathematical operators to write formulas in Excel. I just demonstrated addition by using the plus sign. Press Shift and equals on your keyboard to make a plus sign appear. For subtraction, use the minus sign, which is just to the left of the equals key. For multiplication, don't be fooled. We will never use the letter X. Instead, use an asterisk or star by pressing Shift and 8. And for division, we'll use a /, which shares the same key as a question mark, just to the left of the right-hand Shift key. So we have 4 symbols that we can use when we build formulas: addition, plus sign, subtraction, minus sign, multiplication, asterisk, and division, /. When you write a formula in Excel, you can type the numbers directly, kind of like how you would when you use a calculator, or you can use references, which you will see are very useful. Our data will often be expressed in numbers, and then we'll use formulas that incorporate these symbols and references to produce some kind of outcome. I think this makes much more sense when you can see examples. If I only ever needed to add numbers like 2 plus 3 or 7 plus 3, then I wouldn't need Excel. But when I need to do more complicated math, the actual calculation will be easy because the software will compute the results. I'm going to repeat what I did earlier with the simple numbers. I'll click in cell F1, then type an equal sign. Then I'll click in cell D1, shift in equals for a plus sign, and I'll click inside of cell E1. Notice that there should not be any spaces in my formula. Here I'm telling the software that inside of cell F1, I would like to display the combined value of the numbers in both cells D1 and E1. Recall that I said you can think about references as signs that point at numbers, so I could describe the formula in another way. Relative to the place where I want the outcome, which is the place where I've typed the formula, I want to combine the values that are 2 steps next door to the left and 1 step next door to the left. I'll press enter. Thank you for your attention so far. Now I can show you the magic of Excel, which isn't really magic. It's just a feature called AutoFill. Select cell F1 and carefully move your cursor to the bottom right corner until it turns into a skinny black plus sign. But be careful that you do not see the 4-way arrow symbol. I'll left click and drag down to cell F4. Now, when I release the mouse button, the remaining values will be calculated. What I see is not what I get in Excel, so I'm going to click inside of cell F2 and take a look at my formula bar to verify its contents. Even though I started with equals D1 plus E1 when I first typed this formula, it has changed to become equals D2 plus E2 in cell F2. I'll press the escape key in the upper left corner to exit from that perspective. I'll click on cell F3 and I can see that this contains equals D3 plus E3, and the corresponding result exists in cell F4. To make the color-coded coordinates appear, first click in any cell that contains a formula, then click inside of the formula bar. Now I can see the blue coordinate is added to the red coordinate. In a simple example like this, it's easy to see which two numbers are being added together, but in more complex situations, this is really helpful. Again, I'll press escape to exit this perspective. I'm going to add another column, and I'll change the color of my numbers to red to give you the sense that I'm intentionally making a mistake in this part of my demonstration. I'll type some more numbers in column E, and notice that as I type, the total which is now in column G does not update. If I click on cell G1 to investigate my formula, I can see that the reference that was previously E1 has changed to F1. And if I click inside the formula bar, the color-coded visualization shows me that my formula only accounts for the original numbers and it excludes the new data in column E. There's a couple different ways I could fix this. I could change the formula in cell G1 to become equals D1 plus E1 plus F1, and then use AutoFill again to update the remaining rows. I'll verify my work by clicking on cell G3, and we can see now that the values D3, E3, and F3 have been added together. I intentionally started this demonstration with a simple formula to build up to this next method for adding up numbers. I'm going to go back to my original data before I entered the first formula. Now I'm going to use a different method for adding these numbers together. This time I'm going to use a function. I'll still start with an equal sign, then I'll type sum, S-U-M. I'll type a left bracket, and finally I'll click and drag to select cells D1 and E1. And even without closing the bracket, I'll be lazy and press enter. Similar to what we just saw, if I click on cell F1 and then click inside of the formula bar, I will see a color-coded visualization of my formula. Notice that the values inside of the brackets are connected by a colon. This indicates a range of cells that includes the named cells and everything in between them. But because I'm only working with two values, there's nothing in between in this example. I'll press escape. And again I can use AutoFill, and the formula will be modified in rows 2, 3, and 4 to point at the pertinent numbers. This next step is going to show you why using a function like the sum function is often a superior choice in Excel. Again, I'm going to add in a new column between these values. But before I add the numbers, I want to show you the formula inside of cell G1. Unlike in the earlier example, this time, Excel has predicted that I would like to include the new values in this formula even before I've entered them. This formula means that the combination of numbers in cell D1 to F1, including everything in between, will be computed. I'll press escape, and now I'll type the same values I used before. The result in column G automatically updates. Using the sum function can also be helpful if I are working in the opposite direction. Imagine I needed to delete the data from column D. Once I do this, the values in the last column will shift from column G to column F, and they will only include the remaining two values in each row. All the formulas I've used so far in this video have used relative references. Recall that a reference is a coordinate that works like a sign that points at another number. The last thing I have to demonstrate for you now is an absolute reference. The format for a relative reference is just one letter and one number. And the format for an absolute reference is going to be $sign letter, $sign number. In many cases, you do want to use relative references, especially when your data is organized in a uniform way like the rows I have here. It should feel intuitively obvious to you that this makes sense because I'm adding up different numbers in each row. But what if I wanted to build a formula that always refers to the same number? I've added some headings for the next part of this demonstration. Now column F is labeled as subtotal, column G as tax, and column I as tax rate. To get easy numbers, I've used 10%. It's important that this value, 10%, is all by itself in a cell. I cannot mix the words tax rate and the number 10% in the same cell for this to work properly. When I want to calculate the tax that pertains to the subtotal, I'll start with the equal sign in cell G2, I'll click on cell F2, press Shift and 8 to manually type the multiplication sign, and using my keyboard, I'll build an absolute reference to cell I2, $I, $2. I'll press Enter to confirm my formula. Beside this, I'll label the empty column tax error. Again, I'll include these values in red to emphasize that I'm intentionally making a mistake for the purpose of this demonstration. This time I'm going to use my keyboard to build the whole formula, instead of clicking with my mouse. I'll start with the equal sign, I'll type F2, it doesn't matter if I use an upper or lowercase f. I'll make the multiplication sign, and I'm going to incorrectly include a relative reference to cell I2. I'll press Enter to confirm my formula. In this first row, we get the same result, 1577.8. So you might not be convinced that there's value in using the absolute reference. But now I'll autofill the remaining values. So far so good in column G. Now keep your eye on the result when I calculate column H. In the remaining rows, zeros appear. Even if you're not a math whiz, you should be pretty comfortable with the idea that 10% of 9,245 cannot be zero. Let's investigate the error. We'll take a closer look at the correct result first. In cell G2, I have the formula F2 times $I, $2, which is an absolute reference to cell I2. I'll press Escape. Now when I click on cells G3, G4, and G5, you'll see that this pattern repeats. I'm always taking the number on the left side and multiplying it by the value in I2. By using an absolute reference, $I, $2, I've locked on to the value 10%. Now let's look at the tax error column. We know that the value in cell H2 is okay, so I'll start by investigating cell H3. Aha! You can see that I've correctly included the subtotal from cell F3, but because I incorrectly used a relative reference to cell I2 in my original formula inside of cell H2, it has moved down one row and is now pointing at an empty cell. I'll press Enter to continue. If I click on cell H4 and also H5, you'll see the same issue repeated. The subtotal has correctly moved down one row from line to line, but the reference to the tax rate has incorrectly moved down one line each time as well. We want to use the unique subtotal from each line in rows 2, 3, 4, and 5. So it's okay for it to move down one row each time, but we also want to lock on to the tax rate in cell I2. Using an absolute reference is the tool that lets us communicate our intention to lock onto this value with Excel. I could have repeated the 10% in cells I3, I4, and I5 to obtain the correct value in the tax error column, column H. But this is much less elegant than having the tax rate appear only one time inside of my worksheet. This is especially true if the tax rate is always the same in each of these calculations. One more thing before I wrap up. It's important for me to have thoughtfully built the formula that I'm using in column G, because if the tax rate were to change, all of the results in column G will update immediately to be correct. I'll click inside of cell I2 and I'll change the tax rate to 8.5%. Keep your eyes on the tax column, column G, when I press enter. Immediately the numbers have updated. Using formulas and functions in Excel simplifies complex mathematical operations. It takes some practice to get used to how this works, but once you've mastered the basics, you'll be able to analyze large amounts of data efficiently.